Section 9.1, Part 2. Lesson objective. Construct a confidence interval for a population mean, assuming that the population standard deviation is known. Lesson objective. One aspect of inferential statistics is estimation, which is the process of estimating the value of a parameter from information obtained from a sample. Let's look at an example. The typical U.S. mobile prescriber sends and receives more text messages than phone calls, according to research released by Nelson Mobile. Say we are interested in the mean number of text messages sent or received for a typical college student, aged 18 to 24, per month. A random sample of 500 college students, aged 18 to 24 years old, yields a mean of 729 text messages per month. How can we use this sample to make inference about the general population? This is what we call our point estimate for the population mean. X bar equals 729. Of course, if we were to construct another random sample of 500 college students, we would probably get a different X bar. Hence, we need the concept of a confidence interval. Definition. Confidence interval for an unknown parameter consists of an interval of numbers. Confidence level represents the expected proportion of intervals that will contain the parameter if a large number of different samples is obtained. The level of confidence is denoted 1 minus alpha times 100%. Now for this class we're going to be using 3 confidence levels: 90%, 95%, and 99%. Confidence interval are in the form point estimate plus or minus margin of error. The margin of error of a confidence interval estimate of a parameter is the measure of how accurate the point estimate is. Consider this confidence interval, 12 plus or minus 2. So if we look at this visually, our point estimate is 12, and using our margin of error 2, we see that the confidence interval would have a left endpoint at 10, because 12 minus 2 is 10, and a right endpoint of 14, because 12 plus 2 is 14. Our point estimate is always exactly in the middle of the confidence interval. So the question is how do we find the margin of error? If you recall, the central limit theorem states that if the sample size is large enough, or if the original population is normal, the distribution of the X bars will be normal. It will have a mean that is the same as the population mean, and the standard deviation, called the standard error, will be smaller and is given by this formula: sigma divided by the square root of n. Because X bar is normally distributed, we know that 95% of all sample means lie within 1.96 standard deviations of the population mean, mu, and 2.5% of the sample means lie in each tail. So let's get a visual. Why is this the case? If we look at the middle 95% here, this has to be 2.5% and this has to be 2.5%, because the left tail plus the right tail has to be 5%, because this is 95%, and all 3 areas add up to 100%. Our mean is the same thing as the population mean, and we can sort of see that this is sort of like empirical rule. If you go about 2 standard deviations below the mean and 2 above the mean, this should catch about 95% of the data. Now applying this to our previous example, our mean would be 12, and if we were to go 1.96 times the standard deviation and 1.96 times standard deviation above the mean, this should contain about 95% of the sample means. So we have our interval of 10 to 14, and we can define 1.96 times the standard error as our margin of error. So if we were to write this as inequalities, we would see that 95% of all sample means would be in this inequality. We have our left endpoint, we have our right endpoint, and we believe that 95% of of x bars would be in this interval. Using a little bit of algebra, we can rewrite this inequality as mu being less than x bar minus 1.96 times the standard error, and x bar plus 1.96 times the standard error, which gives us what's commonly written as x bar plus or minus 1.96 times the standard error. And again, this is in the form of the point estimate plus or minus the margin of error. So hence we have our formula for margin of error, 1.96 times standard error, if we are computing a 95% confidence interval. Let's do an example. This is our Facebook example from the previous video. Use the social networking website data and a 95% confidence level to find the margin of error for the mean number of friends for all users of Facebook. Assume that the population standard deviation is about 53. Round your answer to one decimal place. Alright, this is our formula for the margin of error for 95% confidence level, 1.96 times our standard error. Our standard error is sigma population standard deviation divided by square root of n. And we know from this example that our assumed population standard deviation is 53. The sample size was 40. So taking 1.96 times 53 divided by square root of 40, we have 16.4248. And if we round this to one decimal place, we have 16.4. So we are 95% confident that the margin of error for the population mean is about 16.4 friends. Construct a 95% confidence interval for the mean number of friends for all users of Facebook. So now we know our point estimate. Now we have our margin of error. We can construct our confidence interval. So recall that our point estimate x bar is 130.8. Our margin of error is 16.4. So the left end point will be x bar minus our margin of error, which is 114.4, and the right end point will be our point estimate x bar plus the margin of error, which produces 147.2. Our estimate for the population mean is between 114.4 and 147.2. Now this is expressing the confidence interval as an inequality. We could also express it as what's called interval notation. We begin with the left end point, put a comma, and then we put in the right end point. We could also express it as the point estimate plus or minus margin of error, and we could also express it as a visual on a number line. This is the formula for any confidence level. Our lower bound, or left hand side, is our point estimate minus what's called z alpha over 2, which is known as the critical z value, times our standard error. The upper bound, or right hand side of the confidence interval, is our point estimate plus our z alpha over 2, our critical z value, times the standard error. Now our requirement is the sample size must be large enough, the rule of thumb is 30 or more, or the original population must be normal. So as we change our level of confidence, our critical value, our z alpha over 2, changes. If we're doing a 90% confidence level, our critical value is 1.645. As we've seen before in our previous example, if we are using a 95% confidence level, our z alpha over 2 is 1.96, and if we use a 99, we use 2.575. Now these values here were taken from the very bottom of table 5. So whenever you need to find these values, just look at the very bottom of table 5. A random sample of 500 college students yielded a mean of 729 text messages per month. Assuming that the population standard deviation is 150 text messages, construct the 90% confidence interval for the mean text message per month for a typical college student. We see that X bar is 729 as our point estimate. Because we are using a 90% confidence level, our critical Z value is 1.645. Our assumed population standard deviation is 150, and our sample size was 500. So our margin of error, rounded off to one decimal place, is 11.0. So we can express this one of three ways. We could say our 90% confidence interval in interval notation would look like 718 to 740. We could write it as an inequality. Mu is in between 718 and 740. Or we could express it as point estimate plus or minus margin of error, 729 plus or minus 11. Thanks for watching.